In this video, we'll deploy and test an Aurora Gateway running on a Raspberry Pi. A Raspberry Pi is a credit card-sized single-board computer developed in the United Kingdom by the Raspberry Pi Foundation to promote teaching of basic computer science in schools and developing countries. The Raspberry Pi 3 Model B was released in February 2016 and costs about $35 here in the United States. Despite its small size, the Raspberry Pi is still a complete Linux computer with 1 gigabyte of memory, and in this case, 32 gigabytes of micro SD chip for storage. So let's get started. We've already installed Raspbian on the Raspberry Pi. Raspbian is a spin-off of the Linux distribution Debian that works well on the Raspberry Pi's hardware. I've already taken the liberty of putting the Aurora Gateway image onto a thumb drive, which I have plugged into the Raspberry Pi right now. And I'm going to go ahead and copy the image itself, which is just a folder called a gateway. I'm going to copy this off to the temp folder just so we have a copy of it. Copy the Raspberry Pi.html file to the desktop just so I have access to it for now. This will give us the steps involved with installing Mono, which the first step we're going to need to do is install Mono. Mono is an open source implementation of the .NET framework. By installing Mono, you gain access to a ton of useful stuff, but the relevant item here is the Mono service executable. So the first command we're going to have to give the Raspberry Pi is we're going to install Mono Complete. I'm going to go ahead and open up a terminal session here. Now this could take a little while, so we're going to go ahead and pause it. Okay, that's done. Next command we're going to want to give it is we're going to install the Mono VBNC. This installs the .NET framework onto the Raspberry Pi. This is usually fairly quick. Now that that's done, we're going to go ahead and fetch a list of available updates for any of these applications, as well as the Raspbian itself. That's done. Now we'll go ahead and apply the upgrade. Now this could take several minutes, so more than likely, well, I'm up to date, so I don't have to worry about it. Normally this might take a few minutes though. Alright, so the first thing we're going to want to do is we want to go and open up the file manager, but I'm going to want a privileged user to do the super user access. So I'm going to issue the command, and I am going to find our temp folder. I'm going to go ahead and put this right into the root, right there. Now I'm going to open up the gateway. One thing we are going to need to do is we're going to copy the script file itself. And we need to put this script file into the etc. Let's go back. etc and then initd folder. paste it. This script file is just simply telling the Raspberry Pi how to run the Aurora software, how to start it properly, how to shut it down properly, such. So we are going to have to give permissions to this file. So I can go ahead and close this up. Back here, we're going to change the mode. We're going to set the execute permissions on the script file itself. And we also want to set the execute permissions on the Aurora Gateway executable. That's done. Next up, we are going to update the script file to start automatically on startup. Alright, that's done. So we should be ready to start the Aurora Gateway. First time we're going to start it, we want to start it just to make sure it seems to run okay. I'm going to open up this window a bit. And we're going to run it using, from the script file itself, using the debug flag, which will allow us to view the Aurora Gateway as it boots up and runs through. So I'm going to clear this. Paste the command with the debug switch, and we'll see if it starts up. Starting the Aurora Gateway service, local path, root gateway, looks good. It's now listening on port 192.168.1.64, port 162 UDP. Now, the Aurora Gateway is now running, but it has nowhere to go with these traps because it doesn't know your trap destination or the web service in the event you're sending the alarms to AlarmTraq over secure HTTPS. So, first thing we're going to do is we're going to go ahead and kill the service just by hitting Control-C, which stops it. We'll go ahead and close that. And we want to go back into the file manager using the super user account. So it's gonna be under root and a gateway. Open it up. As I mentioned before, we did create two new configuration files. First one being the app settings.xml, and then there's the devices.xml. The app settings XML, we're going to go ahead and open this up, and what we need to do is we need to populate either the secure alarming URL in the event of using secure alarming over HTTPS, or the SNMP trap destination if we need to be sending the alarms to AlarmTraq around the web service, or in the event the web service cannot connect with the Aurora Gateway. We also want to make sure that the community string listed here matches the community string of the communications manager sending the traps to the Aurora Gateway. So I'm going to go ahead and edit our new secure alarming URL. In this case, it's going to be secure.alarming.alarmtraq.com. secure.alarming.alarmtraq.com. That looks good. I'm not going to give it an SNMP trap destination right now because we don't need it. Community string of public, we'll program that in. And the system also generates a random product ID. The product ID is a 10-digit number starting with the digit 5, which will identify this Aurora Gateway to AlarmTraq once it receives the alarm. So let's go ahead and save this. And we'll close this up. And we'll run the startup again using the debug switch. Expand this out a little bit more. Web service URL, it recognizes it. And as we can see, it updated the primary web service at https securealarming.alarmtraq.com, updated the devices being the initial gateway, and it went ahead and sent an alarm to AlarmTraq saying that the Aurora Gateway service has started. And I should be able to go into my browser and hit the server in New York to be able to, no, I guess not, we don't have it up here yet. Let's bring it up. https securealarming.alarmtraq.com. I'm going to go ahead and log in, and I'm going to look at the wall board here. We should see there it is, Raspberry Pi at 75,149. Looks good. Aurora Gateway service has started. Fantastic. So we'll go ahead and close that. So the next thing we're going to do is we're going to go ahead and log into the Avaya Communications Manager. And we're going to issue the command. ALM SNMP conf dswitch with the IP address of the Aurora Gateway. As we can see in this case, we are listening on port 192.168.1.64, and we're using a community string of public, just like we told the app settings file. We'll go ahead and write that. Once that's written, we're going to issue the test inads command, which should send a trap to the Aurora Gateway. And there it is. As we can see, we received the alarm message from the product ID we have, testing inads link. On the Communications Manager side, got a reply from the Communications Manager. Test message was sent to inads, and the reply was call acknowledged. So now if we go ahead and look at our AlarmTraq, we should see, yeah, right there, from the Raspberry Pi, the Aurora Gateway, and there's the CM 7.1 testing inads link reported by AlarmTraq. So that's it. We can verify the testing by getting out of here, which will send one more trap. We'll close that up. We're going to take a look at the file. We can now test it by running starting the service. It's going to ask for a password. And we'll check the status of the gateway. As we see, it's active and running. And we can go back in and take a look at the folder itself. a gateway folder. We now have a logs folder which are created on the first install, and we have an event log. We'll open up the event log and we'll see what happened. As you can see, when we first started it up, the Aurora Gateway service started. We hadn't set the secure alarming URL, so we stopped it. We went ahead and set the secure alarming URL right there. It started up. The Aurora Gateway sent a trap saying that service had started, and then we received a testing INADS link trap from the Avaya Communications Manager, and it sent that trap up through the web service over secure HTTPS. The alarm was returned as acknowledged from the web service. The INADS SNMP alarm acknowledgement signal was sent back to the Communications Manager, letting it know that the alarm was received. And that's about it. Thank you very much for watching the video.